Now, the next thing that we're going to talk about is surface weather conditions. So the weather conditions at individual locations. And if you actually notice on this map, there are these different symbols. So right here, there's an asterisk. No, that doesn't mean Barry Bonds. It actually represents snow. You see these dots right here. These actually represent rain. These 3 line signs, almost looks like an equal sign, but with 3 lines instead of 2. These actually represent fog. Over here, these kind of awesome looking R symbols, these actually represent thunderstorms. And then back here, these actually represent different types of showers. And there's actually many different symbols, and there's another link I posted that actually shows some of those symbols. But these symbols are also a part of a bigger model that we as meteorologists use to identify weather conditions at individual locations. So, as a meteorologist, when we talk about weather conditions, we are interested in many different things. We're interested in temperature, we're interested in dew point, we're interested in precipitation, cloud cover, air pressure, wind speed, wind direction, and that's just to name the most important ones. And if you've taken my regular Met 10 lecture class, you've heard me talk about all of those. And I assume if you've taken it with somebody else, you've probably heard it from them as well. So with that said, there are so many individual pieces of information that if we were to plot them all on a map, it would be overwhelming. And so one of the things that we actually do to condense it into a still convenient, relatively easy to use method is using what's called the station model. And what I have right here on this screen is an example of a station model and the different things that the model is telling you. So let's talk about this real quick. So I'm going to break this up into 3 sections: the left, the center, and then the right. So left, center, and right. First, let's talk about the left. In the upper left-hand corner, you will always see air temperature. So this is the temperature that you feel when you walk outside. And that's pretty much it. So if in this case, the temperature is 57 degrees. So if you were asked to give me the temperature, voila, it's 57 degrees. This middle area actually represents any particular precipitation or fog or thunderstorms. There's all kinds of different symbols that can be put here, but this just represents certain weather conditions. Usually precipitation, but even things like smoke can be put there. And again, in order to actually be able to decode this, make sure that you click on that link that I provided in this assignment, and it's also available in the Weather Studies manual. Here in the bottom left, this number here represents the dew point temperature. And I'm not going to go too into depth about the dew point temperature. We're going to talk about it more in depth when we start talking about moisture and clouds. But for right now, what you need to know is that this is the temperature that the air needs to be cooled to in order for dew to form on the ground. So if you've ever woken up in the morning and you see dew on the grass outside, it's because the air temperature cooled to the dew point. And when that happens, a condition called saturation is achieved. Again, a little beyond the scope of what we're talking about today, but just know, lower left-hand corner, dew point. All right, now let me talk about this center. So in this center, you see a circle with some kind of filling in it. This one's completely full. And then sticking out of the circle is a pole with these feathers on the edge of it. So let me break this down. First off, the center circle is actually where the station is located. And in the center is some kind of shading representing sky cover. And there's many different sky covers. So there's cloudy, partly cloudy, mostly cloudy. And again, the key, the legend that I posted a link to will actually give you a breakdown of each of those individual cloud covers. The next thing I want to point out here are this pole and then these feathers at the edge of it. So think of this like a flagpole. So here's the flagpole, and then these are the flags on the edge of it. So the first thing we want to talk about is where the flagpole is pointing. And this tells us the wind direction. Now in meteorology, when talking about wind direction, we actually are talking about where the wind is coming from. Not where the wind is blowing towards, but rather where the wind is coming from. And the reason why we do that is because wind brings things with it. Wind blows rain in with it, wind blows clouds in with it, wind blows hot air with it or cold air with it. So we want to know where the wind is coming from because we want to know what is it bringing with it. So for example, last quarter, before I recorded this video, there was a fire in Butte County, and the winds that we experienced here in the Bay Area were blowing from Butte County, and hence we got all that smoke. And the way that this whole direction thing works is just like any map in this class. So I've told you before, north is on the top, south is on the bottom, west is on the left, and east is on the right. And that is true in all cases. So this works just like a compass. In this case, the flagpole is pointing up and to the left. It's pointing more up than to the left. And this is what we would call north because it's pointing up, and west because it's pointing to the left. And since this one's actually pointing way more up, it's actually almost closer to north than west, we would call this north-northwest. If it was pointing more at, let me use an arrow here, if it was pointing more like this, that would be northwest, or like this would be west-northwest. And you'll encounter a few of these throughout this investigation. All right, I'm going to delete that now. Let's see here. I'll erase all link on slide. Good. Okay. So the next thing I want to talk about are these feathers at the edge. So these are the flags at the edge of the flagpole. And you notice that there are two different flags here. One is longer than the other. So here's what these represent. These tell us how fast the wind is blowing. And you can indicate how fast the wind is blowing by looking at how many flags are there and how long they're pointing out. So whenever you see one that is extended all the way out, like fully out, this longer one, this is what's called a full barb. And this actually represents 10 nautical miles. 10, I'm going to put KTS here, so 10 nautical miles. Meanwhile, this shorter one represents 5 nautical miles per hour. And then adding them up, 10 plus 5, the wind speed here is 15. So 10 plus 5 is 15. Now in some cases, the wind speed may only be 5. And how can you tell a half feather from a full feather? Well, in the case of just a 5-mile-an-hour wind, you'll see that half feather, but it won't be all the way at the end of the pole. It'll be a little inside from the end of the pole. So for example, if the wind here was just 5, we would actually completely erase this. Sorry for my terrible drawing skills. And we would just see what looks like that right there. So if the squiggles kind of confuse you, put your thumb over the long pole, and you would just see something that looks like this. You would see just a half tick a little away from the edge of the flagpole. All right, the last thing I'm going to talk about here, and this is the most difficult one, is sea level pressure. And let me erase this again. And sea level pressure actually deals with what is the sea level pressure at your location. Most locations aren't at sea level, and so in order for us to accurately determine the presence of high pressure and low pressure systems, we calibrate all locations to sea level. And what you notice here is there's a 3-digit number. But if you actually remember from investigation 1, most sea level pressures are usually around 1,000, 1,015 millibars. Some can be below 1,000. And so how do we convert this to an actual sea level pressure? Well, the way that we do that depends on how large the number is. If the number is less than 500, so less than 500, as is this case, if it's less than 500, what we are going to do is we are actually going to stick a 10 in front of it. Now, before I continue on, let me just really stress here. When I say stick a 10 in front of it, I don't mean add a 10. Because when people hear add a 10, they think plus 10. So I strongly recommend don't say add a 10, just because that could confuse you, and then people start plus 10ing and it ends up being a whole mess. No, you stick a 10 in front. So you stick a 10 ahead of the first digit. That's the first thing you do. The second thing you do is you place a decimal between the last two digits. And there's your pressure, 1,010.7 millibars. Now, Terrence, what would happen if this number was greater than or equal to 500? Well, I'm glad you asked. If this number was greater than or equal to 500, so greater than or equal to 500, what you would actually do is a very similar procedure, but instead of a 10, you would stick a 9 in front of it, and then put a decimal between the last two digits. So, for example, let's say the pressure was, I'll say 678. The number you see in the upper right-hand corner was 678. That's greater than 500. So what I would do is I'd stick a 9 in front, and then place a decimal between the last two places, which would give me a pressure of 967.8 millibars. This requires a little bit of practice. If you actually are looking for additional practice, check out the New York Science Teacher Station Model Lab. It is a very useful lab, and there's a lot of really cool practice there. But you'll also get lots of practice in this investigation.